Packet lesson 1-3, Introduction to Story Problems. Now, don't be confused. We're not actually solving for anything today. We're just kind of getting warmed up, learning how to set things up. Some of these are extremely simple, straightforward. Some of them are a bit challenging. So let's just dive in. I'm going to skip these warmer-uppers because you guys, hopefully, you've already watched the warmer-upper. But here we go. 8 is less than a number. Well, that's just going to be x minus 8. Not bad. Don't like this sample problem, but let's just deal with it. 8 is, if you fixate on that, especially because it's in large letters, you might think it's equals, but you got to read the whole thing. 8 is less than a number. So already kind of confusing, but let's just move forward here. List 3 consecutive integers starting with 4. All right, 4, 5, 6. List 3 consecutive odd integers starting with 7. 7, 9, 11. List 3 consecutive even integers starting with 6. 6, 8, 10. Now, what I think this is asking us to do is list 3 consecutive integers using algebra. So we're going with this. We're letting that first guy be x. The next one is 1 bigger than the original, and 6 is 2 bigger than the initial one. And list 3 consecutive odd integers. All right, well, here's my odd integers. I start with that one, x. Next one, 2 bigger. The final one is 4 bigger than the original. And like I said in the pre-lesson, see this right here? From 6 to 8, there's a difference of 2. From 6 to 10, there's a difference of 4. So this is the same for consecutive even integers. So we're going to refer back to this a few times. So, all right, let's just tackle this first sample problem. Well, example 3, but this one's actually like a geometry problem. A rectangular garden is L feet long. Now I need you guys to listen because I do this one a little bit different, I think, maybe than most people. But for me, it's the easiest. It's a rectangular garden, so I know these two are the same. I know these two are the same. It says it's enclosed by 200 feet of fencing. So think about this, you guys. If I go from point A to point B to point C to point D and then back to A, how far have I gone? 200. Now, look at the question. It says, how wide is the garden? Notice they said, let the length be L. So I'm going to go ahead and put that L right here. Now, here's how I'm going to think of it. They want us to label this. How long is it? Well, think about it. If this is the entire perimeter, then what is it only halfway? Well, that'd be 100. And if this already has L taken up, this guy has to be 100 minus L. For me, I think that's just the easiest way to look at it. Next one. The perimeter of an isosceles triangle. Better know what that is. That is a triangle with two sides the same. This is referred to as the base, and these are the legs. There's a leg, there's a leg. With that in mind, the perimeter is 500. Again, that's from point A to B, down to C, and then back to A. That's the whole perimeter. So just think of it as a fenced-in area. That's the total perimeter. And it says one of the legs is L. So that is L. It's got a length of L. It could be 5, could be 10. But that means this has to be the same. Basically, it's saying how long is the base. Well, if we know that this is L and this is L, we added those together, we'd get 2L. That's already been the fence that we've used. And if there's only a total of 500 centimeters of fence, I got to subtract that from what's already been used. And that's what the base is. That's what's left over. That's the representation of the base. And that's kind of the flavor of today's lesson. This one's a little bit trickier. It says Patrick's father is F years old. So I'm going to label that accurately. The father is F years old. That could be 50, 60, 75, whatever. Now his son, Patrick, is 3 years less than half his father. So I'm going to take his father's, take half, and then I'm going to subtract 3. That's an algebra representation of Patrick's age. Now watch the trickiness of this wording. What is the difference of their ages? Well, you got to think like this. Who's older? The dad. Well, what's the difference mean? Subtract. So it's implying take the older or the bigger number and subtract the younger age. Now, this is an excellent time where parentheses come in handy because I need to subtract all of it, which means I need to distribute the negative. So I get f minus 1/2 f plus 3. Notice these two negatives make a positive. And what's f minus 1/2 f? That's 1/2 f plus 3. That is the difference of their ages. I know that's a weird looking answer, but it's just algebra, warming up with good old algebra. This next sample problem, in my opinion, is the trickiest, but we'll see. Ashley has S songs on her iPod. It starts out so simple. So she's got S. That's not a 5, that's an S. Here it comes. If she had 100 more, it's like, okay, let's consider the situation where you added 100 songs to her iPod. It says she, meaning Ashley, with this number of songs on her iPod, would have half as many as her sister has. Here comes the twist. Question is, how many does her sister have? So you're going to have to think backwards. If this is half of what Ashley's sister has, then the sister must have double this. And I think that's the twist in this problem. And there's the answer. If you wanted to distribute that through, you could. So either one of these is fine because we're just looking for representations of answers. I think that's the hardest one. So notice it says length and width of a rectangle. Well, let's go ahead and draw a rectangle now. Remember, these two sides are the same, so are these. And it says the length and the width of a rectangle are consecutive, consecutive even integers, but this time there's only 2 that we have to deal with. And it's telling us let the length be L. All right, well the length is L and the length is L. The length is typically longer than the width, so this is slightly different. So if they're consecutive even integers, this one has to be 2 less than the length, and this has to be 2 less than the length. Slightly different than your pre-lesson, because they told us what to label the long side. Now it's saying find the perimeter. Well, that'd be just adding up all these. L plus L plus L plus L is 4L. And adding those two negatives would give us -4. And there's your representation of the perimeter. Area, remember, it's just length times width. Well, the length is L. The width is right here. So that'd be L minus 2. Good news? I don't think they expect you to multiply that out. They just want to kind of transition from the geometry to the algebra. A couple more. 2 buses leave the depot at the same time. One heads east, that jumps out at me, and the other heads west. That's just a simple way of saying, hey, one of them goes this way. Let's call that east. Another one goes this way. We'll call that west. But it does tell us some details. Remember the distance equals rate times time formula that I gave you in the pre-lesson? This problem is going to expect you to understand that. So this says one of them heads east at X miles an hour. So that's the rate of the bus leaving this way. So I'm going to call that X miles per hour. And the other heads west at half that speed. So this bus's speed is half that bus's speed. And it says after 4 hours. Guess what that is? Time. So I got to multiply that by 4. I got to multiply that by 4. And it says how far apart are the buses? Well, remember what this represents. It represents distance. So this would give me 2x. This would give me 4x. And these represent distances. So I'd add them together and I'd get 6x. And that's a representation of how far they are apart. Last two problems, I think. Yes. So example 9. Same sort of problem, but watch the picture change. A family driving to their vacation destination traveled for 3 hours at r miles per hour, then decreased. So you see this fam, here comes the fam. They're going to go this way for a certain scenario, and then they're going to continue in the journey with a second scenario. So remember the formula, distance equals rate times time. So it says, a family driving to their vacation destination traveled for 3 hours, that's the time, at r miles per hour, that's the rate. So I have r times 3, rate times time, and then decreased the speed. Remember, this is the speed, by 15 miles per hour. So on this scenario, they slowed her down a bit, and then they traveled for 2 more hours like that. And it says, how far have they traveled? Well, this represents 3r. If I just distribute this, I'd get 2r minus 30. And I'm going to, this is a distance, and this is a distance. So if I added these together, I'd get 5r minus 30. And that represents the distance. Last problem. Two angles in a penta. Uh-oh, what's a pentagon? 5, 1, 2, 3, 4, 5. All right, not bad. But it says two of the angles have a measure of 3x. So I'm just going to label them like that. It says, what is the average of the measures of the other 3 angles? All right, well, it gives us a hint here. It says the sum of the measures of the angles of a pentagon are 540. So what it wants us to do is take the average of the other 3 angles. So that means this one, and this one. I got to show a representation of what they are and then divide by 3 to find the average. Well, that tells me if there's 540 degrees in a pentagon and I have to subtract this and this, that would give me 6x. This represents what's left for these 3 angles. And then it says find the average of the 3 angles. So I got to divide that by 3. This one can be reduced. So we're gonna. 3 goes into 540 180 times. 3 goes into 6 twice. And this would be your simplified answer. And that finishes your packet lesson. And this, on page 17, begins your actual opportunity to try them yourselves. Have a good time, and dive in. Don't fear the story problems.